Hey guys, welcome back. I hope you had a good spring break. Sorry that we can't be together in person, but we will be doing our best online. So if you could please pull out your 5.2 notes. These were given last Wednesday before break. So if you have them, pull them out. If you don't, go ahead and try to print this from Google Classroom. You can find it under the classwork section there. If you don't have access to a printer, just do your best writing these examples down and solving along with us. It's best if you can do it with me and not just listen to me do them and watch me, but to go ahead and do them yourself as well. Okay, so homework, just to clarify before we start, you will have this entire homework and it will be due Thursday at midnight, so you can go ahead and turn it in. Whenever you finish it, you can just email it to me and I will grade it then. So we did 1 through 6 in class together. For those of you who weren't there or didn't get this in your notes, go ahead and maybe take a picture of this and put it in your notes. This is really core to what we will be doing. And this is kind of the idea of trigonometry. A lot of this comes back to geometry when we learned about SOHCAHTOA. So in geometry, you learned sine is opposite over hypotenuse. Cosine, sorry, that's supposed to be cosine, is adjacent over hypotenuse. And tangent is opposite over adjacent, or can be written as sine over cosine. Both ways are very helpful, so we will be writing it both ways, so make sure you know both things for sine. And then cosecant is going to be the inverse of sine, so it's going to be 1 over sine or the reciprocal of sine as well. Those are called reciprocal functions, so it can be written as hypotenuse over opposite. And secant is 1 over cosine, or can be written as hypotenuse over adjacent. And then my cotangent is adjacent over opposite, or it can be written as cosine over sine. So all of this is in reference to an angle on a triangle, and we're going to call that a theta. And theta just represents any angle. So the one on the opposite side of the angle, that side is going to be my opposite side. So that's where that O is coming from. Okay, the side across from my right triangle or my right angle is always the longest side and is always my hypotenuse. So that's how we can find hypotenuse. It's always across from the right angle. And then the remaining side that is touching my angle is going to be the adjacent side. So we can see here that the hypotenuse also does touch. Oops, sorry, I didn't mean to press that button. The hypotenuse also touches my angle. So the hypotenuse is technically also adjacent to my angle, but the hypotenuse is always the longest side and across from the right triangle. So that means that remaining side I have left is my adjacent side. So that's where those values come from, and we will be using them to solve different things in this unit. So let's go ahead and slide down. We're also going to do a little bit of a quick review of the unit circle. So here we have our unit circle. My unit circle is a very helpful tool we use in this class to help us solve different things, and it has angles and points corresponding to it. So when you see all of these, first off, when you see all the things in degrees, like 30 degrees, 45 degrees, all of those are angles. And the sides next to them, like pi over 6, pi over 4, those are also angles. The one are angles in degrees and the others are angles in radians. So when I'm looking for 5 pi over 3, I can find 5 pi over 3. Oops, that was really big. But also whatever is next to it, that angle next to it is also the same thing. So that 300 degrees and 5 pi over 3 are the same thing. One is in radians, the other is in degrees. So we can see these points here underneath that are correlating to that point. So at 5 pi over 3, I have 1/2 square root of 3 over 2. Now, what are those points telling us? Those points, actually, that x, y value there, tell us my sine and my cosine. The x value is the cosine, and the y value is the sine. So for this problem, it's asking me for the sine, and then in the instructions, it asks for a few more things as well. So we'll do that for the first three, and then the last ones we'll just leave them the way they are. So the sine is going to be that second value, negative square root of 3 over 2. The cosine of 5 pi over 3 is the first value we see there, which was 1/2. Okay, so that's where these values are coming from. Sine is the second value in the parentheses, and cosine is the first value in the parentheses. So cosine is the x, sine is y. Tangent is a little trickier. Remember, we can write tangent a few different ways. Tangent is adjacent over hypotenuse, but it's also sine over cosine. So let's rewrite that as sine over cosine. Sine was negative square root of 3 over 2. Divided by, so that's just my numerator right there, 1/2. If I have a fraction in my denominator, the only way I can get rid of it is by multiplying by its reciprocal. So we're going to multiply both sides by 2 over 1. Here, the 2's are canceling, the 1's are canceling, my denominator cancels out, and here my 2's cancel as well. So I'm just left with negative square root of 3 over 1. Negative square root of 3 over 1, but that 1 divides into it to just give me negative square root of 3. So my final answer is just tangent equals negative square root of 3. My cosine was 1/2, and my sine was, oh my goodness, that. Okay. Yeah. Let's leave it at that for now, but I'll give you a little trick. Well, let's talk about it right now. So we can write tangent as sine over cosine. That's what we did there. And then we multiplied by the reciprocals and they cancel. But what we see when I do it as sine over cosine, first off, my denominator of sine is 2. And my denominator of cosine is 2. And when I do sine over cosine, and I cancel out I try to get rid of the denominator, so I multiply by the reciprocal, those denominators there cancel. Okay? So even if you are having trouble tracking with that, that's okay. What you need to know is that these denominators actually will cancel, and so you don't need them when you're using the unit circle. When you're not using the unit circle, the denominators would still cancel, actually, as long as they're from the same triangle, because it's just the hypotenuse, right? So the denominators are going to cancel. So instead of writing the whole thing and then writing it as a fraction and then canceling it out, instead of doing that whole thing, you can just write the tangent as the numerator of sine divided by the numerator of cosine. So you can rewrite it as numerator, it's a long word, of sine over. I'm just going to abbreviate the bottom as NUM for numerator of cosine. So we can just look at the numerators. It's going to speed us up a lot. So let's look at this next one. This next one's giving us tangent right away. Okay, tangent of 3 pi over 2. 3 pi over 2 we have here right on the bottom. And my sine is -1 and my cosine is 0. So in this case, I could do numerator of sine or numerator of cosine, but it's just straight up giving it to me as it is. So I like to write out sine and cosine before I go ahead and find the tangent anyways, because I need to know what they are in order to find the tangent. So I think we said the cosine here was 0. The y here was -1. So sine is -1. So my tangent is just sine over cosine, -1 over 0. Well, anything divided by 0 is, hopefully you're saying to yourself, undefined, because you'd be right. Okay, I'm going to give you a minute. Pause the screen. Do number 9. Okay, hopefully you did pause it and did number 9. If we look at the cosine here, the cosine of 0 is going to give us 1. The sine of 0 is going to give us 0. And the tangent is actually going to give us 0 over 1, which is not undefined. It's actually 0. So That's number 9. The next 3, we're just going to do what it's asking us to do. We're not going to find sine, cosine, and tangent just for time's sake. So 5 pi over 4, 5 pi over 4, let's find that value on our unit circle. And we're going to be taking cotangent. So cotangent is cosine over sine. Or we can rewrite it as the numerator of cosine divided by the numerator of sine, because when I'm doing these, I don't have to worry about the denominator. Okay, so that's like the shortcut way to write cotangent as well. So the numerator of cosine, in this case, if we look at our unit circle, is negative square root of 2 over, just negative square root of 2. That's the numerator. The numerator of sine is negative square root of 2. So if I'm going to write it out, I'm going to have negative square root of 2 divided by negative square root of 2. Well, anything divided by itself is just 1. So that simplifies to give me 1. Okay. Go ahead and try number 11. I think you guys can do it. Pause it to do it. So at number 11, we have this point here. Okay. So if I'm trying to find the cosecant, first, I need to figure out what the secant is. The secant of pi is, sorry, not the secant. First, I need to figure out what the sine is, because secant is the reciprocal of sine. Where's my eraser? There it is. So secant is the reciprocal of sine. So first, we're going to find the sine of theta. So sine of pi is 0. We can see that my y value here is 0. So the sine of pi is 0. So the cosecant of pi is going to be 1 over sine. We said we can write this 2 ways. One way is 1 over sine. The other is as the reciprocal of sine. Well, in this case, sine is just 0, so it's easier just to do 1 over sine. And once again, we get undefined because I can't divide by 0. Okay, looking at the next one. The secant of 5 pi over 4. Well, let's go find 5 pi over 4. We actually looked at it before. It's negative square root of 2 over 2 and negative square root of 2 over 2 are those points there. So when we're looking at secant, the reciprocal of secant is cosine. So we're looking at this first value here. So if the cosine is negative square root of 2 over 2, then my secant is going to be 2 over, or negative, we can just put the negative in front, 2 over the square root of 2. Now, normally I would be done at this point, but I have a square root in the denominator, which we're not allowed, so we need to get rid of that by multiplying by the square root of 2 over the square root of 2. Okay, this gives us the square root of 4 in the denominator, which is 2. And in my numerator, I'm left with negative 2 square roots of 2. And if you notice, we have a 2 in the numerator and the denominator, so they cancel, and I'm just left with negative square root of 2. That 2 does not divide into the square root because you cannot divide a square root by something that's not a square root. So it doesn't work like that. Cool. One more. And then number 14 is on a different video because it took weird last time. The next value is going to be finding, when it says solve each triangle, it wants us to find everything. So let's start with saying what we know, and we'll find what we don't know. I know angle A is 48 degrees. I know angle, well, I don't know angle B, so I'll write that down. And I know angle C. And when we do angles, we're going to use capital letters. And when I do sides, I'm going to use the lowercase letters. So I don't know side A. Actually, let's talk about which sides are which. So the side across from the corresponding angle is that side. So the side across from C is going to be side C. The side across from angle B is going to be side B. And the side across from angle A is going to be side A. Now, This is not to get confused with adjacent, hypotenuse, and my opposite side. Those relate directly to the angle. So A is not necessarily my adjacent side. It's however it is, wherever it lays in reference to my angle. So in this case, the only side I know is B, which is 16. So the first thing I'm going to do is see what I can solve right off the bat. And hopefully you can recognize, oh, I know two angles. I can find the third one pretty easily, because all angles in a triangle add up to 180. So we can say 180 equals 48 plus 90 plus whatever angle B is. Okay, when we go to solve for angle B and subtract that 48 and 49 from, or 90 to both sides, we get B is 42. So we can find that angle. The next bit is a little trickier. If I want to figure out what side A is, I'm going to have to use SOHCAHTOA to do this. So in order to use SOHCAHTOA, we have to figure out what these angles are in reference to my angle. So we can see this angle here is 48 degrees. That's the angle I know. So, and we cannot use 90 degrees as our reference angle for SOHCAHTOA. It just doesn't work like that. So 48 degrees, the side opposite of it is actually A. So A is not the same as the adjacent. It's going to be the opposite side in this case. The side adjacent to it is B. So B is adjacent to it. And then the side across from the right angle is my hypotenuse. So C is my hypotenuse. Okay, so bear with me here. If I'm trying to find